about this one, just give you a chance to think it through. So go ahead and pause the video and come back when you're ready. So here, welcome back. Here, Soraya has 6 tasks that she has to do at work, but she only has time to complete 4 of them, and she needs to decide in what order to do them. This is a pretty realistic scenario. I find myself in the situation all the time where I'm like, okay, I have to do, R, S, T, U, V, X, Y tasks, but I know I don't have time for all of that. How should I prioritize my task? So what you can recognize in this problem is that she has 6 tasks total. She's only going to be able to do 4 of them. And she has to decide in what order to do those tasks. So those 3 characteristics should say to you permutations. This is NPR. I need to know what my N is, and I need to know what my R is, and I'm dealing with permutations. So that's the function that I'm going to use on my calculator. So what we do, right, is we simply say, okay, order matters, that's permutations. My N is the total number of tasks, which is 6. I go ahead to probability, choose NPR, enter, hit my smaller number, my R, which is 4. And then when I hit enter, my calculator is literally going to just throw out 360, and that's my answer. Again, questions that are pretty nice and manageable when you've got the right tools. So you might be able to guess what type of problem the next one is going to be, because it's the one that you haven't practiced yet in this session that's related to this whole topic. So go ahead and check out number 6 and see if you can figure out what it's asking you to do. Run the numbers, see what you get, and come back when you're ready. Welcome back. Here we have a club with 24 members forming a 3-person committee to plan a fundraiser. What's the number of different 3-person committees that can be formed? So in the previous problem, Soraya had to order her tasks. But in this problem, even though we are picking a small group from a larger group, there's nothing about ordering in the language of this problem. We just want committees of 3 people. How many different committees can we make? So we look at the situation, order doesn't matter. Okay, fine. What is our N? 24. What is our R? 3. We're going to just punch that in using our combinations key. When order doesn't matter, not key, but the combinations selection. When order doesn't matter, and yet I am choosing a larger group from a smaller group. Plug it in, 24. Probability key, choose NCR. Enter, plug in 3, right? And your calculator will spit out 2024. And that's your answer for question number 6. So great work on these, more advanced topics. But again, I hope you're recognizing that having the right tools makes them much more manageable and gives you an opportunity to grab more points on the GED math test. So advanced topics don't even, questions involving advanced topics don't even need to be necessarily harder, which is really good to know. And maybe you'll think the same about the next thing that we're going to talk about, which is our 3D figures. So what do you need to know about 3D figures? Well, first of all, just think about the definition of 3-dimensional, right? What makes something 3-dimensional? Something that's 2D is basically flat. Like you could just represent it on a piece of paper. You could cut it out of one piece of paper. I could cut out a picture of a triangle or a square or a circle or a rectangle. But 3D figures have that additional dimension. Not only the height and width that we kind of have come to expect, or the base and the height, right? Or the length and the width, different ways that we think about 2 dimensions, but then this 3rd dimension of depth, right? And the way that we define the different dimensions does depend on whether we're dealing in 2 dimensions or 3 dimensions. And you'll see that the way that we define the various measurements that you can make of these 3D figures depends on the type of figure that we're looking at. So when you have a 3D figure, there are a couple different things that you can calculate. Right? If you measure the space inside the shape, that's going to be your volume. And that can be helpful in terms of thinking about which dimensions you're using to calculate, which we'll see in a little bit. And if you're measuring the total surface area, right, what's on the outside, that's going to be the total area of all of the faces. And you can see that these are kind of analogous, right? The area of the faces is the surface area. So surface area is like all around the outside. So although it's called area, this is actually like the circumference or the perimeter of a two-dimensional figure. And the space inside is the volume, but what's inside in 2 dimensions is what we would have called the area. Right? So everything is related, right? But we're just adding that third dimension. So some examples of 3D figures that you might see on the GED math test include a rectangular prism. Now this is just anything that you would literally think of in everyday terms as a box. Right? When you think of a box, you think of something that has all right angles and has sides that are shaped like rectangles. And that's your rectangular prism. It is a fancy way of basically saying a box. Right? So a rectangular prism could be a cube if all of the edges have the same length. So it's a square, like a die, I guess I should say, a die is a cube. This is an example of a rectangular prism. Right? So, you know, and you can have any different combination of side lengths, but if all of those edges are the same, then it's a cube. Okay. Now, here is what we call a right prism. So this is a more generic type of a shape. A rectangular prism has all of its faces are rectangular. A right prism can have its bases, and we say that prisms have 2 bases, right? So here's base number 1 here, like this guy in the front, and then here's base number 2, this guy in the back. Right? In a right prism, the bases can be any other shape other than a rectangle or a square. Right? If the base is a rectangle or a square, then it is a rectangular prism. Otherwise, it's a right prism. And so here you can see that the base has 5 sides. So it's a pentagon. It's a pentagonal prism. You could have a triangle in your base. You could have a hexagon in your base. But the reason why it's called a right prism is that all of these edges here are at right angles to both of the bases. So that if you stood it up on its side, it would be completely uniform, going from bottom to top. So that's your standard right prism. And again, you could have bases with different shapes here. Then we have our cube, which again is just a special kind of rectangular prism. Right? A cube is a type of rectangular prism. And the cylinder. So the cylinder is, you know, that shape like a soup can where you just have a circle on the bottom and a circle on the top, and then all the way around the outside. And so again, for each of these figures, we can calculate surface area and volume. And we've got formulas for all of those that you can access on test day. So although we'll show them to you and we'll use them here, you will always have access to them. It's not something you have to memorize. You've got your sphere. You can calculate you know, volume and surface area for a sphere, which obviously is just a circle taken into 3 dimensions. Every single point on the outside of that sphere is the same distance from the center as every other point. Pyramid, which starts out like a rectangular prism, but then it has to come up to a point, right? And then a cone, which starts out like a cylinder, but comes up to a point. And you may notice that there's a relationship between the formulas for pyramids versus rectangular prisms, right? I may say to myself, well, this pyramid is kind of like, that's not really the tool that I wanted. So I may say that the pyramid is a little like the rectangular prism, except that it comes to a point, and the cone is a bit like the cylinder, except that it comes to a point. So we'll see how that might have an impact on the calculations that we use to find volume or to find surface area. But the other thing before we leave this slide is I want to point out to you something that we're showing you on the cone. because most of these dimensions are dimensions that you're pretty used to. You know, you've got length, you've got width, you've got height, you can calculate the area of a base, you can calculate the perimeter of a base. You know about pi, you know about radius when it comes to circular or spherical objects. But what you may not be familiar with is this idea of slant height. Right? And you're going to be using slant height if you have to do surface area calculations for pyramids or cones, because they have that slantedness to them that other shapes don't have. So slant height becomes important when you're dealing with cones or pyramids. So let's go ahead and take a look at these formulas. This is the formula sheet, or part of the formula sheet, that you'll have available to you when you take the GED math test. You may already have a version of this printed out, especially if you have, or printed out or in a book, especially if you have the Kaplan GED prep book. And so this is also obviously in your PDF if you have the PDF. But if you have none of those sources, you can go ahead and take a screenshot of this and then keep it open in another window to work, to do your work through this session. So if you need to take a screenshot, you can do so using this link. So if you ever need to take a screenshot of anything, there will be instructions there that will tell you how to do it for whatever operating system you're working on. So if you would like to pause here, go ahead and get instructions to take a screenshot. If you're not sure how to do that, then you can do that. And when you are ready, come back, and we're going to work on a wide variety of different 3D shapes, calculating surface area and volume. So again, just to be aware that surface area is always SA here, right? Volume is V. LWH are length, width, and height. Base, you're told here, and this is important, this is good to know, right? Base is the area of the base. Notice it's a capital B because it's an area measurement. The L, W, and H are all lowercase, and R is lowercase because it's just one-dimensional. The B is uppercase to kind of remind you that it's two-dimensional and you have to calculate that area. Right? Whereas P is the perimeter of the base when you're given that. And as we saw earlier, S, which comes into just two of these formulas, is your slant height. Slant height. Okay, so as I was mentioning earlier, if you look at a right prism, actually I think I want to look at the rectangular prism. Now let's look at a right prism. A right prism has a volume that's just base times height. But then when you look at a pyramid, which is the one that shrinks to a point, the area is base times height times 1/3. So you have 1/3 as much volume in a pyramid as you would have in the same shape if it were a rectangular prism. Okay, and likewise with cylinder and cone, right? You have 1/3 as much volume in a cone that shrinks to a point as you would have if you had the same cylinder. Okay, and just note that again, the only place where you use the slant height is to calculate surface area of cone and a pyramid, because cone and pyramids are the ones that are slanted, and the slant height is on the outside. So we use that slant height when we're calculating the surface area around the outside, because that's where the height is equal to the slant height. When we're calculating the volume of the pyramid or the cone, we just use the regular inside height, which is right here, H, as you're used to seeing H, referring to height. Okay, so that's a lot. That's a lot of information, but don't worry, we're going to put all of this into practice, and you're going to see the various situations in which these various formulas are applied and how they work. So again, go ahead and get a hold of a copy of this, because I don't want you to have to keep going back to this part of the video to work on these problems, so that you can refer to it when I give you some time to work on each of the following problems independently. So let's dive into our 3D geometry practice. Okay, a box, two identical rectangular bases. We would like you to please find the surface area and volume of the closed box, which means, right, we're just going to say you just need to figure out what is the surface area of the outside of it and what would its volume be. So take the time that you need to retrieve the correct formulas and apply them and come up with your numbers, and then we'll check back with you. Good luck. All right, so our formulas. Notice the way that we have described the formula. You'll see this throughout this practice that we'll be doing. The surface area for the formula of it, we're first describing what it is and then giving you the actual formula that you're going to apply, right? So the surface area is the combined area of all of the 6 sides, and that's going to be equal to 2 times length times width plus 2 times length times height plus 2 times width times height. So really what this formula is asking you to do is find each of the combinations of 2 sides, because that's going to give you each of the areas of the 3 different shaped sides. And then because you have 2 of each of them, 2 tops and bottoms, 2 left and right sides, and 2 front and back sides, each one gets multiplied by 2, and then you just sum them together. So the key here is just make sure you grab all of your different combinations. Volume is going to be just length times width times height. So this is a nice simple shape to deal with. So surface area. Again, notice that we have our different combinations. We have 4 times 5, 4 times 3, and 5 times 3, right? So go ahead and punch that right into your calculator. Just be careful when you do so. Make sure you punch everything in correctly, and you're going to get 94 square feet for the surface area. For the volume, length times width times height is just 3 times 4 times 5. And that's going to be equal to, looks like 60, right? 60 cubic feet. So again, notice in terms of your dimensions that a surface area dimension is 2 dimensions. Even though it's a 3-dimensional figure, area is just 2 dimensions. It's just the space, the area around the outside. That's going to be in square feet. Whereas for volume, then you're bringing your 3rd dimension in, and so instead of having just square feet, you're going to have cubic feet for your volume. All right, so good work with the rectangular solid here, or the rectangular prism. Let's go ahead and bump it up. Here we're asking you to deal with a pyramid, and this first question asks you just to find the surface area. And so you can see that we've given you a crucial piece of information that you need to calculate the surface area. So go ahead and retrieve the formula for this one, figure out what numbers belong in that formula, calculate, and come back when you're ready. So surface area of a pyramid from our formula sheet is 1/2 the perimeter of the base times the slant height. Okay, good. So we were given slant height, and we know that the base of this is a square. Okay, so we need to calculate the perimeter of the base and the area of the base, and all told, our formula is going to look like this. 1/2 perimeter times slant height plus base. And then when it comes to surface area, right, that's going to be our formula. That's all we have to do here. So S is the slant height, that's 5 inches. P is the perimeter of the square base, so we're just going to add the side length 4 times, because it's a square, all the sides are the same. So that's going to be equal to 12 for our perimeter. And then our base is going to be, if it's square, we just take the length of each of one of the sides, they're all going to be the same, and multiply it by itself, right? Base times height is just side times side when it comes to a square. So we have 9 square inches for the base. So we're going to go ahead and multiply our 1/2 times our perimeter, which is 12. Let's just go ahead and kind of put this all together, right? 1/2 times our perimeter, which is 12. We calculated that here, times our slant height, which is 5. We were given that in the diagram, plus the area of our base, which is 9, which we calculated by taking the side length and squaring it. And then you just punch all that into your calculator. 1/2 of 12 times 5 is 6 times 5, which is 30, plus 9 is just 39. And that's our surface area for this pyramid. So next, bet you can guess what's coming up next. We're going to ask you in this next example to calculate the volume of a pyramid. And so what you can see, we'll just pop back to the previous example. For surface area, we gave you the height that's on the outside of the pyramid, right here. However, for volume, which is the space inside, we're going to give you the inside height. of the pyramid. Right? So here we have our 6 centimeters is the inside height, which you're going to use to calculate the volume. So go ahead and give this one a try. Come back when you're ready. Welcome back. So again, pyramid, we're given kind of the definition of a pyramid, then asked to find the volume. So formula for volume is 1/3 times the area of the base times the height. Now the height perpendicular to the base again is that inside height. So it's area of base times height. And again, area of base times height would be just for a rectangular prism. We're only taking 1/3 of that. So don't forget to multiply by that 1/3 because it could easily be one of the incorrect answer choices is one where that 1/3 is not taken into account. So just be careful with that. Here's our formula, 1/3 base times height. All right, what's the base of this pyramid here? Well, it's got a square base with 5 centimeters on each side. What's the height? We were given the height, it's equal to 6. And so our volume calculation is just 1/3 times 5 squared for our base. 5 squared for our base right here. 5 times 5 is our base calculation, and then our height is 6, which we were given. And so that's going to be 25 times 1/3 of 6, which is 2. 25 times 2 is 50. So if you don't have to get out your calculator, it'll save you a little bit of time. But if you feel like you want to make certain of your calculation, then that's what your calculator is there for. Okay, so the volume of this pyramid, 56 cubic centimeters. Let's take a look at another example. A cylinder. So go ahead and try out this cylinder question. We're looking here for surface area and volume. So please go ahead and calculate each of those using the appropriate formulas and come back when you're ready. Surface area and volume. So surface area, this looks like a really complicated formula. 2 pi times radius times height plus 2 pi times radius squared. Now, okay, it may be helpful to remember this formula. And again, you don't have to remember because you can always check back to your formula sheet if you need to. But I do think that it's sometimes helpful to sort of think about where the formula comes from. So if you look at this little piece right here, let's kind of highlight this piece in purple. This piece here, pi r squared. You know what that is. That's the area of a circle. So the 2 times pi r squared is the area of the circle on the top and the area of the circle on the bottom. Right? So if we're looking at surface area, we need to take into account the top and the bottom, each of which are circles. So pi r squared is the top, pi r squared is the bottom, so this is the top and bottom here. And then what about this crazy 2 pi rh? Well, you may also notice that you know something about this 2 pi r, right? Where have you seen 2 pi r before? Well, 2 pi r is the circumference of a circle. So what you are doing, and in fact, I'm just going to color in the top here to sort of distinguish it from what I'm doing, right? This is your area of the top and area of the bottom, pi r squared, right here. Then, when you want to figure out what else do you have to account for here, right? You have to account for this part on the outside, this part. So if you were thinking of this as a can, this is flat, so it looks kind of like it may be a tuna can, and I only wish I had a tuna can handy to show you this, but I did not plan ahead, and I apologize. Think about that tuna can. If I wanted to find out the area of what's outside those on the side, what I could do is basically just like rip off the label, right? And if I ripped off that label, it would actually be a rectangle. But because it had to go all the way around that circle, its length would be the circumference of the circle, the circumference of that can. And its height would just be the height of the can. So this is where this 2 pi rh comes from, right? So this is around the outside, the vertical side, There is only one side, right? It's circular. That's the vertical. Okay, so that's where our surface area calculation comes from. All you need to be able to do is plug in the R and plug in the H, and as long as you do it carefully, you're good to go. And the volume for a cylinder is just area of the base times the height, which is pi r squared times h. So those are our two formulas. So surface area, 2 pi r h plus 2 pi r squared, and volume is pi r squared h. So let's go ahead and plug in for surface area. All right, for surface area, 2 pi. Radius is 5. Our radius is 5 as we were given on our figure. Our height is 3 as we were given on our figure. And then we plug in the height, the radius here as well. And then we just go ahead and punch that into the calculator. Now you may be given answer choices with pi in them, but if you are not, you would just use your, you can use your pi key, right? If you just had an answer with pi in it, then you'd want to know what is 2 times 15 plus 2 times 25, and you would add them together, and that's how many pi you have, right? This is 30 pi, and this is 50 pi, and that would be 80 pi. And if you wanted the actual value of that, then you'd go ahead and multiply by your pi key, and it would be 200, something more than 240, because it would be like around 250 or something, because that would be the approximate value of pi. And then to go ahead and plug in for the volume, pi r squared h. Okay, pi is pi, r squared is 5 squared, h is 3, and this is going to be 75 pi cubic units for the volume of our cylinder. All right, so let's go ahead and take a look at pyramids. So what we're going to show you on this next problem is just to make it a little bit easier to see what we're doing here. You're going to use the first cone. I think I just said pyramids, but I meant to say cones. We've got two different cones here because we're asking you on this one slide to calculate surface area and to calculate volume. And so what you may recall, and if you don't, that's fine, just go ahead and grab your formula sheet. The more you use these, the more they're going to work their way into your memory, is that for the surface area of the cone, you are going to be using slant height. Again, you want the outside area, so you're going to be using the outside height. Whereas for the volume, right, you want to be using, you're concerned with the volume inside the cone, so you're going to be using the inside height, which is that 9 right there. All right, so go ahead and see if you can retrieve those formulas, plug in accordingly, and see what you get, and then check back when you are ready. So surface area of a cone, right, is going to be equal to, again, take a look at this. Look at the second term in this formula. It is pi r squared. Well, that's just the area of the base, right? And so we're adding to that pi r times the slant height. Okay, fine. So area of the base plus the area of that actual coney part of it is going to give us the total surface area of this closed cone. So we can plug in for that. However, we've also got a volume formula, so let's just get that up here as well so that we're ready to do all of our plugging and checking all at once. The volume of a cone is equal to 1/3 pi r squared h. So again, this pi r squared h part, this is the volume of a cylinder, pi r squared h. Right? That's the volume of a cylinder. For a cone, we're taking only 1/3 of that. Okay, so you can see the relationship between a cone and a cylinder there. So if you plugged in, hopefully what you got was that, let's see, for our surface area, we are looking at pi times the radius, which is 8, times the slant height, which is 4, plus pi times the radius squared. Radius is 8 again, plug that in, and we're going to get 32 pi plus 64 pi, and that's going to add to 96 pi square units altogether. And for the volume, 1/3 pi r squared. Okay, 1/3 times pi, which is just pi. R squared is 2 squared because our radius is 2, and the inside height that we use to calculate the volume of a cone is 9. So we've got 1/3 times pi times 4 times 9, which is the same as pi times 4 times 3, because 1/3 of 9 is 3. So you can simplify that calculation and potentially do that one in your head. So volume and surface area of a cone. Let's give you one last opportunity to work on 3D figure. Here we have a sphere. So one last application, find the formulas, apply the formulas. We've only got one measurement here, radius, so it can't be too bad. So give this one a try. Pause your video, come back when you're ready, and we will review. Surface area and volume of a sphere. Surface area is 4 pi r squared. Okay, so again, it's like we're taking pi r squared, which is the area of a circle, and like expanding it out so it can be the whole surface area of the sphere. And to do that, we multiply by 4. Okay, and volume is 4/3 pi r cubed, right? So here we just have this one dimension. The only measurement we have is the radius. So to get from that one-dimensional radius to a 3-dimensional volume, we actually have to cube the radius. And then we have this fraction 4/3. It's also part of our formula. So to get the surface area, let's see, our radius is 10. So surface area is 4 times pi times 10 squared. Well, that's just 400 pi. And to get our volume, 4/3 times pi times the radius cubed is 4/3 pi times 1,000, right? 10 cubed is 1,000. And so if we take 4/3 of 1,000, 1/3 will be 333, 333.33, repeating forever. Multiply that by 4, and this is the number that we get. This is one that you're almost certainly going to use your calculator for, because of that big number and the way it comes out not in a not pretty way when you have to divide by 3. Okay, so I hope that we did a lot of this. Was actually in this last section of this session, I'm sure you'll agree, was a lot of rote plugging and chugging. And so that's all that's required with 3D figures. Make sure you understand what each variable stands for in the formula. Make sure you know how to choose the right formula, and just that you're careful when you do your calculations, and that you pay attention to whether you're solving for surface area or whether you're solving for volume. And 3D shapes are very, very manageable. So let's go ahead and review what we did in this chock-a-block session. We started out with systems of equations, and we looked at 2 different ways to solve them algebraically, as well as considering how systems of equations are related to the coordinate plane. And again, the links between systems of equations and the way we handled them algebraically, and between that and between concepts related to the coordinate plane are absolutely huge. So get as good of a grip on those connections as you can. Make sure you're understanding what slope is, how it shows up in the equation, what it means if 2 lines have the same slope, what it means if they don't have the same slope, what do you have to do to get 2 lines to intersect, all this kind of stuff. And that the intersection is just that point at which they intersect. It's got an x value, it's got a y value. You can solve for each, as long as you have 2 distinct equations. We talked about factorials and the ways in which factorials are used, both potentially by themselves, but very often in the combination and permutation formulas, and how we use that fundamental counting principle to solve questions that ask us to consider different options for various spots, positions, choices, events within a given scenario. Okay, and then finally, 3D figures. It's all about the formulas, right? And so you'll find probably as you practice that some of your geometry formulas, naturally work their way into your brain. You don't have to work too hard to memorize some of those more complicated formulas, because you're going to be able to look them up. Okay, so I think I've probably mentioned a few times in this session that it's important to keep practicing with these concepts. Again, lots of good practice in the Kaplan GED book. Also, if you attend live sessions, you will find that we don't necessarily cover all of the problems in the live sessions, so you can always practice those questions by yourself and then come and watch a recorded session in which we will always cover all of the questions, so that you can get more input, because we have